Hi, I'm going to talk about types of pressure system for water supply. Well, we have different types of pressure systems. The, the first one are the gravity systems that use elevated tanks, pressure from the waterhead, and have a simple and low cost but variable pressure. We have variable speed pump, VFD system that it's a regulatory control adjust pump speed by demand. The energy is efficient and stable, but it's more expensive. We can have a hydro pneumatic system that use pump and pressure tank. It maintains constant the pressure and needs power and maintenance. We can have series or parallel pumps that where in series increase the pressure and parallel increases the flow rate. So we can have different pump types like centrifugal, diaphragm positive displacement, and submersible multi-stage or multi-stage. It's last are for factories, and centrifugal is more for residential type. About the information model, we can use the Bean methodology, where we can use we can use information in different applications like Revit MEP, Navisworks, Beam 316, WaterCAD, or AutoCAD Map. Thanks.
Hi. Now I will explain some key design details and technical considerations for suction systems. From hydraulic point of view, the suction pipe should be short, straight, and with few fittings to reduce energy losses. The flow velocity must stay below 1.5 meters per second and at least 5 to 10 pipe diameters of straight length should be kept before the pump. It's also essential to make sure that the available suction head is higher than the required suction head to avoid cavitation. Installing a foot valve or a strainer helps prevent solids and keep the system prim. From a mechanical perspective, the pump and motor must be properly aligned and mounted on a rigid base. The suction line should include check valves and air release valves and allow easy access for maintenance. In Ecuador, designs must comply with standards such as NTE INEN 1108 for water quality, RTE INEN 094 for pressure pipes and fittings, and the Ecuadorian Construction Code, which includes seismic protection requirements. Using certified materials, avoid air pockets, and ensuring easy inspection of bulbs and filters are key to maintain safe and efficient water supply systems. Thank you.
Hi, my name is Luis Valladares, and I'm gonna continue the presentation with the impulsion considerations. Well, first we need to know what is the impulsion line. The impulsion line, also called the discharge line, is the pipe that carries water from the pump outlet to the storage tank or distribution system. First, we have the hydraulic considerations as the pipe diameter. The discharge pipe must be properly sized to keep the flow velocity between 1.5 to 3 meters seconds. In low velocity, we need large pipes and it's higher cost. And high velocity is excessive energy losses and water hammer. Also, in hydraulic consideration, we need to see the head losses. That is, the total head loss in the pushing line includes friction losses and minor losses to fittings, elbows, valve, and transitions. And then we have the operational and maintenance consideration as priming that ensures the system filled with water before starting the pump. Also, the leak testing perform hydrostatic pressure test before operation. And dry valve is placed at the lowest point to allow complete drainage during maintenance. And finally, slope, providing a slight slope to facilitate air removal and drainage. Finally, we have the mechanical and installation considerations. We need to ensure that these devices are put in the installation as the check valve that is installed right after the pump to prevent water backflow and protect the impeller. The gate valve placed after the check valve to isolate the pump for maintenance. The pressure gauge measures discharge pressure and helps detect operational problems. A relief valve installed at point heights to remove trapped air and avoid airlocks. The surge protection devices like relief valve or air chambers prevent water hammer. And finally, support and anchors keep the pipeline stable, aligned, and free from vibration.
System pressures, we have the gravity feed that shows that is simple and reliable. It provides or it's going to have water reserve because the system works with tanks, and this is the less, so this doesn't have the mains dependency, but it has low pressure that it's connected with the inconsistent pressure. According to if the floor is higher, it's going to be a lower pressure. So this also has the space intensive. I mean, it's going to be a lot of space to work with this system. We have the images of the system. And continue with the combi boiler system. We have this works with high pressure. It saves space, but also works heating water uh, according to the demand. But this systems has main dependency, and it's going to have the flow limits according if all the outlets are working, or yes, it depends on the demand. And it also has a slow recovery if the combi boiler is smaller or a bigger one. And lastly, we have the unvented pressurized system that it works with high pressure and flow, and it has consistent pressure in all the floors, and it also is flexible or has flexible installation, but the cost is going to be a little bit higher than the others. It also has mains dependency, and it has safety risk. So this is going to we have to take care of this system because it is this. And thank you.
Hello everyone, I'm going to talk about the example of aquarium pump calculation. Okay, the scenario is designing a pumping system to lift water from a deep submersible well to an elevated storage tank for a single family home. In this example, we have 5 parameters. The first one is required flow rate with units liters per second, geometric head with units meters, the total pipe length with units meters, and pipe diameter with units meters, and estimate pump efficiency without units. Okay, the steps are four steps. First step is calculate water velocity. With this equation, step 2 is calculate friction head loss. With this equation, step 3 is calculate total manometric head. That is the parameter before geometric head, and calculate friction head loss, and this result in this value. And step 4 is calculate required hydraulic power. With these numbers, with the total manometric head and required flow rate, have a with this characteristic curve, we select a pump. Thank you.